So if you too want a simple solution for all your projects, then keep watching, as today we're going to build a more professional, clean, modular and scalable RTOS template. Welcome to more Little Man Builds. So let's start today's coding adventure with a quick recap of the project so far. Most of the code sits within our main.cpp file. We have a button and a listener task that's monitoring all the press events. Taking care of how it's done is the universal button library, which also could be called our hardware abstraction layer. We have a handler task that's driving our DC motor. The code instructs the ESP32 MCPWM library what to do, and then this library takes care of how it's done. So why is all of this important? Well, this project is a full start to finish upgrade on a Power Wheels electric vehicle, and the button works exactly the same way as the toy's accelerator. It's just on or off. And having RTOS is extremely important, as imagine that we couldn't stop the vehicle because something was interrupting it within the loop. So let's give the task some context. Firstly, let's define a state manager, which monitors all the input states across the entire car. This could eventually be a play pause button for the radio, a switch for the lights, or in today's case, the accelerator, and we still use our universal button library. Next, we define a PowerDriveHandler that provides the car with instructions for power usage, like maximum speed available, as you wouldn't give a toddler 100% power, right? And it also drives the car, like moving forward or in reverse. For communication, we only need to take a snapshot of the current button state, as it's not a stream of ever-changing data. If it was, I would use queues, which we will delve into in another upcoming video. So definitely hit the subscribe button if you want to stay up to date on this journey. For today, however, I'll be using a new library I'm calling SnapshotBus, and in part 2 of this video, I'll show you how to use it. The result of all these changes is a much cleaner main.cpp that acts like a musical conductor, just orchestrating what's happening, setting up the hardware, defining priorities, and creating tasks. Also, a quick thank you and shout out to all the guys who've given me feedback or tips along the way. The YouTube learning process is honestly pretty difficult, so I definitely appreciate all the comments. I read everything and definitely will get back to you if you have any questions or things like that. So again, big thank you for helping me on my YouTube learning journey. So the first thing we're going to do is create a new folder in library, and we're going to call it StateManager. Then we're going to add 2 new files, StateManager.h, and another new file, StateManager.cpp. In our library, we will also create another folder called PowerDriveHandler. So let's add our header. Now we want to add a class called StateManager. Now, the first thing we're going to do is we're going to add what's called a task trampoline. Let's chuck this in here. And secondly, within the private variables, we will effectively add our run loop. So I'll try to come up with a simple analogy. Imagine you've got a universal phone charger plug that's FreeRTOS, and it can only plug into one basic socket, which is a generic pointer or void star. But your phone is the state manager object and has its own special connector. The trampoline is this little adapter block, so FreeRTOS plugs into the adapter plugs into your phone, and now the boring universal plug can charge your fancy device. So linking back to the code in front of us, FreeRTOS can only start a plain C function with a generic pointer. This tiny trampoline takes that generic pointer, turns it back into my state manager object, and then calls run. And inside run is the real main loop that we're running here. I'm certain this will all make sense very soon. So next we have our StateManager.cpp, so we can do exactly the same thing. We can drag and drop the header. And now we need to write a main run loop. And here's our main loop for this particular class. We can say debug line, hello state manager, and v task delay until. I really hope that wasn't too complicated. Let's do it once more, and we put it into our PowerDriveHandler. We take our default header. And we have our main run loop. Let's go into our PowerDriveHandler.cpp file. Again, drag and drop our header. And we can basically take the same code, copy and paste this one across into here. And except we want to change this one to PowerDriveHandler. So hopefully that makes sense. Let's do a few more double checks along the way so we can get out of these files for now. The first thing I'd like to check is just to make sure that you are actually using the build flags of source/lib, which will allow you to look for these files under the library here. Just a quick check. Next thing I'd like to do is just update our app config file. So I've been playing around with my debugging templates, and I'm just going to update these again. Just keep improving them each time. Let's change this one. I'm going to call this application configuration settings. Still got our namespace config. But instead of this, let's change this to button timings. And we'll put this within a namespace. Button. So that was just a quick cleanup to just change the namespace so that we don't get confused. We can close this. We're going to include our StateManager.h. Going to include our PowerDriveHandler.h as well. Now, this is no longer listener. This is going to be StateManager. Now we no longer need function declarations or any of the contexts. So we can go straight into our setup. For consistency, let's just clean this up a little bit. Now here, the problem is that we've updated our namespace. So we need to now say it's within button. And there it is. We don't need listener context. So we've still got our motor setup. That's exactly the same, except we don't need the handler context. Now our RTOS creation is the same, with the exception that let's get rid of all these comments because we no longer need them. And this time we're going to separate them, and we're actually going to put the second task on the ESP32's second core rather than the first core. The RTOS tasks. Now we can delete everything under here because these are no longer needed and this is no longer needed. So we can delete everything else. Now let's compile this and see if it works. So we have no errors. Let's throw it across to the ESP32 and see what it says. Now you can see that we've got two tasks running on two different cores of the ESP32, giving us our basic hello world. By the way, if you're enjoying today's content, smash the like button or please consider subscribing. It really helps me out with the algorithm and I'd love for you to join our community. So this does compile, but our task trampoline is actually expecting an object and we've not implemented this. And it's also likely if there's a null pointer in the mix that the application will crash. So let's fix this now. So the first thing we're going to do is add a new library. So we can go down into libraries and we can look for SnapshotBus, which I've also written. We can add this to the project. And the second thing we're going to do is add a new folder to our source directory called include without the capital. And then we're going to include that within our build flags. So we can also add that new file and we're going to call it input types.h. And we don't need this one anymore. So here I'm going to do a big copy paste and we'll briefly explain what's going on. This file includes some simple aliases to make our life a little bit easier and keeps things a bit cleaner in the actual files. We have our string names for each logical button. We have some static checks, some utility functions. So in this case, we get a human readable name for a button index, and this one prints a human readable button edge press or release between two snapshots. So I'm not going to go through this in too much detail. All we need to do is include it. So let's save that and keep going. So first we have to go into our StateManager and we need to include some new libraries. So include our universal button. We're going to include SnapshotBus. We're also going to include a snapshot model. And I'm now also going to include my input types.h file. Under my StateManager, we need to create a constructor. So again, I'll just copy and paste this. So this takes a button handler instance and an instance of the snapshot bus. And then we also need some private variables. Let's just create another private section just to keep things clean. And we'll call it button, point it to some buttons, published input state frames. Go into StateManager.cpp. We're going to construct with references to the button handler. So we go StateManager. This is our initial publish. Now we can update our loop here. So let's update the state of our buttons. Then we will create a fresh snapshot. So let's say we build a fresh snapshot. So let's quickly have a look at this one. So going back into our input types, our input state takes the namespace snapshot, model, state, and simply takes the number of buttons. So this is a bit set of all the different button states, all the zeros and ones for our entire project. Next, we're going to say buttons. And we do not need our debug line any further. So we've updated our StateManager.h and StateManager.cpp. Let's close both of these. And now let's update our PowerDriveHandler. So we also need to include some new libraries. We also need a constructor for this class. So we will say PowerDriveHandler. By the way, if you're enjoying today's content, smash the like button or please consider subscribing. It really helps me out with the algorithm and I'd love for you to join our community. Okay, so it's expecting some private variables as well. Notice here that I'm getting an error because it's saying that it has no member accelerator. So we also need to update our app config file. So currently it's called test button, but we want to give it some context for the project. So let's call this button accelerator. We save that within our app config file. We go back, can hover over here, and now everything's working as expected. So let's update the PowerDriveHandler.cpp file. So the first thing we can add is we can add a config assert. So we could say these are sanity checks. Motor and bus must be valid, which reminds me that we should also do this within StateManager. So let's quickly add that. So now we can jump down into our for loop. We don't need our debug line anymore. So let's start with a constant input state. So this is our current input state, which we take from our bus. So let's peek at the bus. So we use the peek function to check or get the current state of the button. So now let's create a simple acceleration method. So we have a press event, which is our current buttons, and we can test our button Excel. Now the reason it's button Excel is if we go back to our PowerDriveHandler, so we made a constant expression. I could also have said in here, instead of creating button Excel, I could also have said that inside of here, it takes this name. So this works exactly the same way, but I believe it's just cleaner to put it this way. So test is also a standard C++ function which checks a single bit and returns true if that bit is set to 1, otherwise it's false. Next, we have a constant float, which is our target %. So if it's pressed, we want to give it max %, otherwise we give it min %. So basically saying if true, we increment the speed on the motor, and if false, we decrement the speed. So if the current %, then we need to drive our motor. So we can set the speed in %, current % with our direction parameter. And then we can have a debug. Okay. So now we can jump out of our PowerDriveHandler and go back and fix our main.cpp. So the first thing we can do, which is optional, and what this is we can define a SnapshotBus yield, and we include input types. So under here, we have a shared input bus. And then under our motor setup, we also have then some managers, which are our objects that we were missing from before. So we can say static, StateManager. Now I left a placeholder for the object, but I never added it in. Now we can put that there. And now we can put our PowerDriveHandler object in, see if it compiles. Great. So let's throw it over to our ESP32 and check it out. So I actually forgot to change the interval loop. Now let's try again. Let's give this a quick test. So pressing the button, noticing there's a little bit of a delay. And if I let go, it decrements again, press it again, increases the acceleration, goes back down, on, off, on, and back off again. So it works really well. So there you go, a professional, clean, scalable, and modular solution for all your future projects. You can find all the code up on our Little Man Builds GitHub page, and if you've got any questions, feel free to drop a comment below. Please also consider subscribing and smash that like button. See you in the next one.